galaxy. For many decades, astrophysicists have told us that at the core of the Milky Way, and 98% of all galaxies, is a supermassive black hole, a hypothetical, quote, region of space-time whose gravitational effects are so colossal that nothing, not even light, can escape. Scientists believe that supermassive black holes explain the stupendous energies and mass measured at galactic cores, and many fantastic electromagnetic phenomena, including powerful galactic jets and X-ray emissions, are attributed to black holes' influences. In fact, for many years, scientific and educational literature have presented the existence of black holes as a matter of settled science, and science media routinely report truly amazing claims about black holes with no skepticism. Of course, a recent example in 2016 was the media firestorm resulting from the pronounced detection of gravitational waves, which was supposedly produced by two colliding black holes a billion years ago. Subsequent such claims have been met with an equal absence of media scrutiny. However, we note that a recent scientific paper entitled "On the Signal Processing Operations in LIGO Signals" should raise serious questions about the validity of the gravitational waves claims. The abstract of the paper, authored by UC Berkeley's Akila Raman, states that the first 5 reported gravitational waves events are, quote, very weak signals whose amplitude does not rise significantly during the gravitational waves event, and they are indistinguishable from non-stationary detector noise. A link to the article may be found in the description box of this video. Unfortunately, this paper has not received a fraction of the media attention that the claimed gravitational waves discoveries have garnered. Paradoxically, these same media also routinely report discoveries that would challenge the very existence of black holes, if astronomers and astrophysicists were willing to entertain such a possibility. But rather than forcing any reassessment of foundational theory, the discoveries are simply presented as exciting puzzles for working scientists. A good example is found in a recent paper on scientists' observation of star formation that is occurring impossibly close to the Milky Way's hypothetical black hole. A Phys.org report introduces the conundrum as follows. At the center of our galaxy, in the immediate vicinity of its supermassive black hole, is a region racked by powerful tidal forces and bathed in intense ultraviolet light and X-ray radiation. These harsh conditions, astronomers surmise, do not favor star formation, especially low-mass stars like our Sun. Surprisingly, new observations suggest otherwise. Scientists using the ALMA telescope discovered evidence of a total of 11 low-mass stars forming within just 3 light-years to the hypothetical black hole. As the Phys.org report notes, at this distance, tidal forces driven by the supermassive black hole should be energetic enough to rip apart clouds of dust and gas before they can form stars. The lead author of the new paper says, despite all odds, we see the best evidence yet that low-mass stars are forming startlingly close to the supermassive black hole at the center of the Milky Way. This is a genuinely surprising result, and one that demonstrates just how robust star formation can be, even in the most unlikely of places. But of course, this is not the first time that our galaxy's hypothetical black hole has mystified astronomers with its behavior. For several years, scientists around the world eagerly awaited the approach of the gas cloud G2 to the supposed black hole. The standard expectation was that the cloud would undoubtedly be, quote, devoured as it entered the black hole's domain. Apparently, the black hole was not feeling hungry, as the gas cloud was left intact to the amazement of astronomers around the world. Hopelessly problematic black hole behavior has been observed at all scales throughout the cosmos. In 2012, we reported on scientists' observations of 2 bright radio spots in the globular cluster M22, which they interpret as 2 small black holes. But standard theory dictates that only 1 black hole at most can exist in the cluster of tightly packed stars. The National Radio Astronomy Observatory reported of the findings. Simulations have indicated that these black holes would fall toward the center of the cluster, then begin a violent gravitational dance with each other, in which all of them, or perhaps all but a single one, would be thrown completely out of the cluster. The author of a paper on the findings stated, We didn't find what we were looking for, but instead found something very surprising: two smaller black holes. That's surprising because most theorists said there should be at most one black hole in the cluster. At a much vaster scale, at the farthest reaches of the observable universe, we see in ever greater detail stupendous electromagnetic phenomena that are not predicted nor explained by black hole theory. As we've reported several times, in 2016, a Royal Astronomical Society press release reported the discovery that, quote, supermassive black holes in a region of the distant universe are all spinning out radio jets in the same direction. A lead investigator, Professor Ramil Dave, said of the findings, "This is not obviously expected based on our current understanding of cosmology. It's a bizarre finding." As noted by Professor Andrew Russ Taylor, these black holes don't know about each other or have any way of exchanging information or influencing each other directly over such vast scales. In the electric universe, such cosmic alignments, completely unexpected by standard cosmology, are both predicted and required if the dominant organizational force is electromagnetism. The electric universe theory proposes that space, across cosmic distances, has a substructure of twisted pair current filaments, with stars and galaxies forming along them like pearls on a string, and having their spin axes aligned along their filaments. Space discovery continues to confirm this prediction, including the Herschel Space Observatory's imaging of vast networks of star-forming filaments. In fact, the phenomenon of spectacular cosmic jets, sometimes hundreds of thousands of light years long, dramatically reveals the tunnel vision of gravity-centric cosmology. Radio astronomers who have measured the electric current in an extragalactic jet have proposed that the black hole creates a powerful magnetic field, which then produces the jet's electric current. But mysterious magnetism will never explain the tremendous electromagnetic emissions that are now routinely detected throughout the cosmos. As we've outlined in dozens of episodes, the concepts of plasma cosmology and the electric universe offer very different predictions and explanations for the phenomena astronomers attribute to black holes. At the center of galaxies is not a black hole, but an ultra-high-density energy storage phenomenon called a plasmoid, a kind of load in the galactic electrical circuit. In a galactic circuit, electrical power flows inward along the spiral arms, lighting the stars as it goes, and is concentrated and stored in the central plasmoid. When the plasmoid reaches a threshold density, it discharges, usually along a galaxy's spin axis. The electric universe proposes this is in fact the source of the stupendous cosmic jets. Indeed, a recent scientific paper reveals that nature is confounding all of cosmologists' predictions about black holes' magnetic properties. A Phys.org report on the findings states, "Black holes are famous for their muscle, an intense gravitational pull known to gobble up entire stars and launch streams of matter into space at almost the speed of light. It turns out the reality may not live up to the hype. University of Florida scientists have discovered these tears in the fabric of the universe have significantly weaker magnetic fields than previously thought." The unsolved mystery that the report acknowledges is, quote, how jets of particles traveling at nearly the speed of light shoot out of black holes' magnetic field. The study co-author states, "The question is, how do you do that? Our surprisingly low measurements will force new constraints on theoretical models that previously focused on strong magnetic fields, accelerating and directing the jet flows. We weren't expecting this, so it changes much of what we thought we knew." As noted in a public comment by Thunderbolt's colleague Chris Weve, the picture which is emerging is of the black hole as non-falsifiable. It really does not seem to matter how many null results accumulate. Since theorists need them to be there, they will continue to insist that they are there. In fact, we have noted a fundamental challenge to the very question of whether Einstein's mathematics predict black holes. As explained by physicist Wal Thornhill in his Space News interview on gravitational waves,
"It's a self-serving myth that Einstein's mathematics predicts black holes. The originators of black hole theory in 1965, including Thorne, chose not to mention that Einstein's October 1939 paper, which they refer to, concludes with, 'The Schwarzschild singularity,' the term black hole had not been introduced then, does not appear for the reason that matter cannot be concentrated arbitrarily, and this is due to the fact that otherwise the constituting particles would reach the velocity of light. Einstein showed mathematically that black holes cannot form gravitationally for the same reason that stars and planets cannot, because the infalling matter begins to circle the centre of mass until the centrifugal force balances the gravitational force. The observational evidence now shows that stars and planets are formed by the powerful electromagnetic force, produced in electromagnetic pinches along cosmic lightning filaments in molecular clouds. Gravitational collapse theory is now discredited by direct observation.
And science media routinely report truly amazing claims about black holes with no skepticism. Of course, a recent example in 2016 was the media firestorm resulting from the pronounced detection of gravitational waves. Powerful galactic jets and X-ray emissions are attributed to black holes' influences. In fact, for many years, scientific and educational literature have presented the existence of black holes as a matter of settled science. Galaxy. For many decades, astrophysicists have told us that at the core of the Milky Way, and 98% of all galaxies, is a supermassive black hole, a hypothetical, quote, region of space-time whose gravitational effects are so, which was supposedly produced by two colliding black holes 1 billion years ago. Subsequent such claims have been met with an equal absence of media scrutiny. However, we note that a recent scientific paper entitled "On the Signal Colossal that Nothing, not even light, can escape." Scientists believe that supermassive black holes explain the stupendous energies and mass measured at galactic cores, and many fantastic electromagnetic phenomena, including